This next question, I'm going to take a look at a question which combines both the ellipse and parabola. It is extremely likely that you will be asked to complete a question similar to this in your mock exam. For the purpose of revision and time, I will only be focusing on the parabola part of this question. This question is from an old 2012 paper, section B, question 6, and I'll post a link to the question in Google Classroom. I would highly recommend you attempt this question in preparation for your mock exam. So the figure shows a logo for riding stables. The curve AB is parabolic with vertex at B. So this is the part that I will be concentrating on. So AB is a semi-parabola, as you can see. Here's A, and it curves up to point B, which is the vertex. So there's our vertex, and you can see that I've highlighted the outline of the semi-parabola. There's also an arc down here that needs to be determined, and you can do that by drawing a chord from P to S and P to A, bisecting them, and the bisector will pass through this central axis line here. You can have a look at the ellipse yourself. The ellipse has been rotated, which makes the question a little difficult, but the same principles apply. Now, I've chosen this question specifically because, unlike the previous video that I've posted on Google Classroom, the parabola is given to us here, but this time we don't have a rectangle. But it's not a major problem. We simply need to draw in the rectangle and then carry out the same procedure. And that's what I'm going to do now. So I can see that the parabola with a vertex at B has an axis, which is this line here, all the way down to S. So I know the height of the rectangle I need to draw, 145 millimeters. The central axis goes from S to A, and that gives me a distance for the bottom of the rectangle, which is 52 plus 52. So the first thing I need to do here is draw the actual rectangle that's going to contain the parabola. And it's going to be 104 wide, 145 millimeters high. So it's a construction line to start with. I'm going to mark off point A. So 52 plus 52 is 104. So from A, 104 millimeters, this point here, and that gives me this point S. I can see that the height of the parabola is 145 millimeters, so that's going to be the height of my rectangle. And the next step is to draw in one side of the rectangle, okay, which will be a line from here upwards, and the height of this line is 145 millimeters. I'm now just going to complete the outline with construction lines for that rectangle. Okay, just having a look at the question again. It's a semi-parabola. If it were a full parabola, I could draw a full rectangle out in this direction, but I don't need that. I just need half of it. Okay, so the next step, the rectangle I've drawn, the same as the last question. I need to divide this line here and the line AS into a number of equal parts. So I'm just going to start up here at the top, drawing a line at any suitable angle. Okay. Then taking the compass, and I'm going to set a suitable distance on the compass, so something like that. It doesn't matter what distance you choose, just don't choose a distance too small like this, because they're tricky to create, and one that's too big will mean that you don't have enough room on this line to complete the division. Because it's an exam, I'm going to stick with 5 equal spaces. More points would mean more accurate parabolas, but for the sake of time I like to stick to a maximum of 5. 4 would work too, but again it would be more difficult to draw a nice smooth curve. So I have 1, 2, 3, 4, and I need one more 5. Okay, now I'm just going to I'm going to index those. So 1, 2, 3, 4, 5. To complete the division of this line into 5 equal parts, I need to take a set square, and I'm going to connect the last point to the opposite end of the line that I'm bisecting. Alright, so then using sliding set squares, if I just zoom out, if anybody wants to see how I do this, I'm going to draw lines parallel from each one of these points. So using your first set square, align one of the edges of the set square with the line you want to copy, and just put the other set square then underneath like this, or maybe over on this side that's just gone out of the picture. And then you can slide one set square along the other, and that will create a parallel line to the first line you've drawn. Okay, now, so I have to reposition my set squares again just to continue with this. And the last thing I would encourage everybody to do is complete your indexing as you go. So that's point 1, point 2, 3, 4 and 5. The next step is to divide up this line from A to S into 5 equal parts as well. It's important that if you divide this line into 5 equal parts, then this line has to be divided into 5 equal parts as well, otherwise the construction won't work correctly. Okay, so same technique, construction line, and I'm going to start from point S this time. I could start from point A and draw a line at that angle. Both approaches will work fine. A line at any angle. You can change the distance on your compass now if you like. Okay, so I'm going to make it slightly smaller than the spacings on this line. It'll still work as long as I don't change this distance while marking off each point along this line. So we're going with 1, 2, 3, 4, 5. When I'm indexing, my point 1 is always closest to where I start drawing this line at any angle. So you can see 1 is here beside the vertex of that angle, and 1 is beside the vertex of this one here. Okay, I'm just going to complete that then by connecting point 5 to the end of the line I'm bisecting, which is point A. And again, I'm going to need to use sliding set squares here to draw a line from each of the other points to complete the division of that line into 5 equal parts. If the bottom set square slips on you, just make sure you reposition it from the first line again, just to ensure that your drawing is accurate. Okay, so now remember everybody, from the question, here's our parabola highlighted with a highlighter there. Let me just zoom in a little bit for you. Okay, so guys, this is the axis of the parabola, meaning this semi-parabola here will be the exact same, or a mirror image, if it were a full parabola, which would be over here somewhere. So you can see they've drawn in part of the other half of the parabola just there. So here's our axis, this is our vertex. Going back to our question, what I need to do now, I need to draw a series of lines from where I divided up this side of the rectangle that go back to our vertex here, okay, which is labelled as point B in the question. So B is our vertex. So again, construction lines. So from my point 1 to point B to point 2, 3, 4 and 5. Even though this last line is not necessary, because the point A, or point 5, is already a point on the parabola. So this is a point on the parabola here. Now we already have that when we draw the rectangle. So the next step then is to draw lines from the bottom of the rectangle that are parallel to this line, which is our axis. So I'm using my t-square and a set square to quickly do that. And now what I need to do is I need to follow the line from point 1, for example, at the bottom of the rectangle up until it intersects with the line from point 1 on the left side of the rectangle. Okay, so we're following these lines until they meet at a point here. I do the same with 2. Three, and 4. And you can see already the outline of the parabola through these points. The last thing I need to do now is I need to draw in the curve. And again, I start off with my 4H pencil, or a light pencil, and I kind of do a trial run of the curve. And I'm just going to have a little look and see how that appears before I heavy it in. I think that's okay, so I'm taking my HB pencil, the one I like to use, and I'm just going to heavy in that curve. Ensuring that I pass through each of those points that I've located. Alright, so a little bit of a speed wobble there, but I think it's okay. So a nice smooth curve. Do not try and kind of go back over it multiple times like that. It leaves it very messy. If it looks okay, then it's good enough. You can see that the construction lines fade nicely into the background there as well. Okay. Now guys, this is the only part of that question that I'm going to focus on today. We've done multiple questions on the ellipse before. I just want to zoom into this a little bit. As I said at the start of the video, this ellipse would be difficult enough to complete because it's rotated. In the case of your mock exams, it's very likely that the ellipse will be in its standard orientation. Okay, so similar to what we've been doing during class. So that question covers the construction of a parabola using the rectangle method when the rectangle is not provided. So again, it's not a major difficulty. We simply draw in our rectangle and then we can complete the construction of the ellipse. I am however going to create a video next on how to find this arc down here at the bottom. Okay, so you can see there that there's an arc given to us that starts at point A and finishes at point S, and we're not given a radius, so it just says R there. So I said at the start of the video, we can draw chords, bisect them to locate the center. I'll do that in the next video.